Good morning, Saintsmen. This morning we are going to tackle the next chapter, which is chapter 3, which is regarding parallel lines and perpendicular lines. So there's a handful of definitions that we want to make sure that we establish as we begin. The first is the notion of parallel lines. Parallel lines are coplanar lines that never intersect. This next portion you may draw if you'd like, but the idea being is that we're going to have two lines. They do have to be in a plane. It's easy to see on your piece of paper where there's a flat surface. Now, these lines are going to be drawn in such a way, consider them like railroad tracks, correct? So these lines here, and of course we have the arrows on either end, these are never, ever, ever going to intersect. Now, it is possible to draw two lines that do not intersect, but they're not on the same plane. I want you to consider that line right there, like just go ahead and just erase one of these guys. And then what you would do is if you were to take your pencil and stab it through the paper, right? Not through that line. So you have one kind of working kind of in and out of the paper and one on the paper. Okay, that notion is what we call skew lines. And skew lines are non-coplanar lines that do not intersect. Okay, so that's the big difference there. Okay, we have the lines that are going to never touch each other. In this case, both of these. All right, versus, of course, what we've already learned about. And you probably already have this note somewhere, which is regarding intersecting lines. And those are just two lines, of course, that intersect in a plane at exactly one point. Now, consider this. If we have that line again, right? This guy. Now, if I were to the same way that I constructed the skew line, right? And by constructed, we just kind of took our pencil and put it above the paper, and it's almost like we're going to stab through the paper, right? And that line has a trajectory, and considering that can go on forever. If I were to stab through the paper, through that line, people are thinking, well, hold on, what would you call that? Well, consider this. That's going to be its own plane, right? That's going to, just those two lines by themselves, while the line that you're stabbing through intersects or exists in the plane that that is your paper, you could create a whole separate plane. Or in other words, could you take another piece of paper and sit it on that line and then kind of sit it against your pencil where it would include both? And the answer is yes. So if there are two lines that are intersecting, right, they have to do so in a plane. Next, we have the notion of parallel planes. All right. So just consider this. If you have from the paper you're writing on, if you were to take another piece of paper out and just kind of float it above your paper, but in the way that you would with lines, right? So that it's going to be equidistant everywhere. In other words, you can't just kind of float the paper at an angle, because if you were to continue that paper, it would, infinitely in all directions. Of course, it's going to intersect the paper that you are writing on. So parallel planes, it's possible, right? We could take two planes, or more, really, that do not intersect. Right. So, long lecture short, some of you have had the experience to travel to various countries. For example, you may have been through, I know that there are some of these in Europe, I once lived, as I've described to you guys, in Colombia. And when I lived in Colombia, the streets functioned in the following way. They referred to these streets that went north and south as carreras, and then all these streets that went east-west were called calles. And it's just effectively two, notions, two words of street. You don't need to necessarily write this down. But if you're trying to get from one place to another, and they of course had these guys numbered, right? 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So it was like a grid, like Battleship. You're here, and then you want to get here, all right? And the most efficient way to do that, the shortest way to do that, would unfortunately is going to involve a lot of turning, right? It's going to mean that you're going to have to go here, then here, then here, then here, then here, right? And that's a little bit crazy. Of course, you can go all the way down 4th and, go and make a left onto 1st and get to your destination. That's going to take a little bit longer. What they have is they have these streets because, to scale, I just drew, 4 streets going up and 6 streets going across. You're going to have, let's say, 30 or 50 streets. That's a tremendous amount of area or a tremendous amount of distance to have to kind of scroll around on this grid. So it'd be nice if somebody actually were just able to do that, right? Just kind of put a diagonal through these things. What they, rather than calling that a diagonal, in Colombia, they actually refer to a lot of these as transversals, which is the same word in English. It's a transversal. A transversal is the line that intersects 2 or more coplanar lines. Okay, so in some of you in other places in Latin America, I think that there's a similar system. Like you see this in like Mexico City, for example. I'll go ahead and just erase some of this stuff. So we don't really need this. All right, so this is what your transversal will look like. So for example, this is the more common transversal we're going to see. We're going to see it when we have parallels, right? The way that we mark parallel lines is the following. When you have two lines, inside of those lines, we're going to have a little arrow that's going to go in the same direction. This denotes that these are parallel, okay? Here, the blue line is my transversal. And this is the where we have a transversal cutting two parallels. That's the word that's commonly used in geometry, is that they talk about a line cutting through two lines. Okay? So, I'm going to throw out a little bit of interesting thought experiment for you, right? So that one, I think it's a little bit clearer to see where the transversal is, right? But watch this. Let's draw a line. Let's draw another line. Let's draw another line. And a little bit of a thought experiment. But which of these lines, of these three lines we just drew, which is the transversal? Which one would it be? The answer? All these are transversals. Nothing has been marked parallel, right? So think about this. This line here, right? And this line here, those two lines are going to intersect. They're not drawn that they are intersecting, but look at this. These arrows mean that they're going to continue ad infinitum, right? There is no little arrow like this that's marking these as parallels, just showing that it was drawn poorly. So all these are transversals, every single one. That's fine. That's something that you can technically do. Okay. I think it's easiest to teach these next concepts using the parallel cut by the transversal. So remember, when we have our lines, okay, so let's draw 2 lines. And we're going to draw this transversal. And these lines are going to be parallel. Sometimes they do this. They'll make the little arrow even just solid. You don't have to do that, but you may. Okay. So this line A and this line B, A is the top line, B is the bottom line. Those are going to be parallel. And the transversal we're going to call C. Now, what we have is line A is parallel to line B. Why would we ever want to write the word parallel again, right? Those 2 slashes mean parallel. It's nice. We love notation. It makes our life easier with regard to how much we have to write. So line A is parallel to line B, and then we have here transversal C. Okay. We have a lot going on here. Moreover, let's number these angles. You guys ready? 1, 2, 3, 4, 5, 6, 7, and 8. Faster. Man, it would be a really busy diagram if I put points on there and then started identifying all those angles by points. And this is why we like that we can number angles as well. Now, we have a few things going on here, okay? First of all, there are 2 types of angles we can distinguish between. There are the interior angles, and then there are the exterior angles. I think it's pretty easy, and I hate using the word easy, right? But I think it's easy for us to see in this diagram the notion between being interior and inside and being exterior and outside, okay? Now, it doesn't have to be always with parallels, right? Because we can have a transversal. We already saw that. We can have a example like this one up above where the transversals are not parallel, right? All these things are transversals. But even there, we can see that there's probably going to be lines, angles that are inside of the diagram, and then ones that are going to be outside. So in this case, and I have a difficult time really defining this, except for just visually demonstrating this to you, but the interior angles we're going to have, there's 4 of them. Angles 3, 4, angle 5, and angle 6. And then I also have the exterior angles. I have angles 1 and 2. There's 4 of these, right? And the last 2, wild guess, of course, would be angles 7 and 8. All right. So within this, we have 4 other types of angles that we want to distinguish, okay? So the first one are called alternate interior. And this is where we're going to pair up some angles. The next is going to be called alternate exterior. Alternate interior versus alternate exterior. Now, take a look at the alternate interior angles, right? First of all, let's just consider these interior angles. The only ones that are going to get paired up are either going to be 3, 4, 5, and 6, okay? Now, remember what it means to alternate. It means to go between 2 things, right? Like the alternator in your car is alternating current. It's going back and forth, positive, negative, okay? And here's the idea with alternate and interior angles. Our first 2 are going to be 3 and 6. And the reason why those are going to be our first two is because they're going to alternate over that transversal. So their interior angles alternate over the transversal, so 3 and 6 are going to get paired together. Let's see if I can erase this without... There we go. So 3 and 6 are alternate interior. And of course, the other two that are going to be paired up as alternate interior are going to be angles 4 and 5, right? So same notion, alternate exterior. I think this is going to be a lot clearer for you, right? I can only use 1, 2, 7, and 8. So of course it's going to be 1 and 8, and then angles 2 and 7. Those are my alternate exteriors. All right, I got 2 more ideas to consider. The next is going to be the consecutive interior. Consecutive interiors include only interior angles, right? It's just going to be 3, 4, and 5, and 6. Okay, so consecutive interior works like this. Now, somebody might say, ooh, I know, interior, well, it's going to be 3 and 4. No, 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 3 and 4 already have a name. Remember, angles 3 and angle 4 are just a linear pair. Right? Those guys are going to be a linear pair. So the consecutive interior, instead, I have 3, and it's not going to be 3 and 4. That's a linear pair. It's not going to be 3 and 6 because that's alternate interior. The only example I have left, or the only possibility I have left, it has to be angles 3 and 5. Those two would have to be consecutive interiors. Everything else already has a definition. Okay? It's going to be, again, along that transversal. It lies on the same line, okay, on the same side of the transversal, rather than alternating sides. So if 3 and 5 are consecutive interiors, of course we know angles 4 and 6 are going to be consecutive interiors as well. All right, next. And last, we're going to refer to our corresponding angles. All of these are in play now, whether they are interior or they are exterior. So we are going to identify all of these that are corresponding. So what they have is when they have corresponding, it means that they have corresponding positions. In other words, they have effectively the same position off of the transversal on one of the parallel lines. For example, I'm going to give you the first one here, and it's going to be angles 1 and 5. Those guys are corresponding. So that's the pair, okay? 1 and 5 are corresponding. So what else would be corresponding? Well, let's look around. 2 and 6. Those guys are corresponding. 3 and 7 are going to be corresponding. And last but not least, angles 4 and 8 are corresponding. Okay? Gentlemen, there are no such thing as consecutive exterior or corresponding exterior, right? The only thing for exterior angles is they can be alternate, okay? Or it's just a corresponding angle, okay? And when that happens, notice one is interior and one is exterior. I think that helps, okay? People will see angles 1 and 7 and they'll wonder, well, what's the relationship? And it's just that they're just both angles. I mean, in this case, we could prove a relationship that's significant, but we're not there just yet. We're going to do that in our next lesson. All right. Finally, for today, we are going to discuss perpendiculars. Perpendicular lines happen when the following happens. So we're going to have a line, and these are going to be intersecting lines. Okay. And I have line L, and I have line J. And lines L and J are perpendicular. Here, there is exactly one line that is perpendicular through L. Okay, and that line in this case is J. What's created here when we have those perpendiculars is the following. They intersect to form 4 right angles. Let's go ahead and fix that spelling. If all 4 are right, then all of them are the same. Remember what we call things with the same measure. All those angles are congruent. Seem logical? All right. And these are the only 2 things we're really going to kind of emphasize today. All right, well, that is all I've got for you for today. So that is our instructional stream. Your homework is going to be posted to Canvas, and it is going to be due. So please have a wonderful day.